Paper 4, paper 2, number 2, it says that the probability of two independent events P and Q occurring together is 1 over 8. It implies P and Q are independent events, but them occurring together it is 1 out of 8. Meaning probability of P and Q occurring together, it is 1 out of 8. Then it says that the probability of either or both events occur, meaning union, it is 5 over 8. The probability of P union Q is given as 5 divided by 8. Then they say find the probabilities of P and probability of Q. Meaning in this case, what you will do, you would say expand this. First of all, the probability of P intersection Q, this becomes P of P times P of Q. What I can do, I would say let the probability of P be equal to X and probability of B be equal to Y. Whereby in this case, this one I know it as 1 divided by 8. This one I've called it X, here I've called it a Y. Meaning from this one I can make Y the subject. Y would become 1 divided by 8x. I call this number 1. But they say the probability of either or both occur, this one. Now this one is probability of P union Q. From additive rule, this can be expanded, giving us probability of P plus probability of Q minus probability of P intersection Q. Now this one we know it as 5 over 8 is equal to this one, I call it X. This one I call it Y. Minus this one, it is 1 divided by 8. This can come this side, giving us X plus Y is equal to this, comes this way, giving us 6 divided by 8. Remember, I can express Y in terms of X, giving us here X plus this one becomes 1 out of 8x. This can be reduced to give us by 2, 3, by 2 you get 4. I can put here over 1 and I cross multiply here, giving me 8x squared plus a 1 divided by 8x is equal to 3 divided by 4. This one will become, this times that, it is 32x squared plus 4 is equal to 24x, giving us 32x squared minus 24x minus 4 is equal to, this is plus 4 is equal to 0. If I divide all products by 4, I'll have 8x squared minus this one divided by 4, it is 8. This one yields as 6x. This one yields a plus 1 is equal to 0. Now this will give me x as equal to 0.5 and likewise x as equal to a quarter in this case. But they had said that find the probability of P and probability of Q. In this case, x is a half. When x is a half, I can find the value of y. From number 1, my y can be 1 divided by 8x, giving us here 1 divided by 8 times a half. This will cancel, giving us 1 divided by a 4. Meaning, when x is a half, my y becomes a quarter. Then likewise, when x is a quarter, in this case, my y in place here will give me y is equal to a half. So I can use this one here. And I say, therefore, the probability of P is equal to a half, and likewise, probability of Q can become 1 divided by 4. We are seeing tree diagram. Let us see examples under tree diagram. Number 1, we have in 2005, paper 2, number 3. They say that a good footballer striker is nursing his injury or his leg. Then they say the probability that his team wins the next match when it's playing it is 4 over 5. So say step number 1, define the events or the letter you would use. You'd say let W represent winning, then let P represent him playing. They say that the probability that his team would win when he's playing it is 4 over 5. Meaning in this case, step number 1, here is playing, here is not playing. That implies the probability that his team is winning when he's playing, we've been told it is 4 divided by 5. And this simply means when he's playing, his team not winning, W complement shall become 1 minus that, which becomes a quarter. Then they say otherwise it is 2 over 5. Meaning the probability that his team winning when not playing, it is 2 divided by 3. Then likewise, his team not winning when he's not playing, it is 1 minus 2/3, which becomes 1 divided by 3. Then they say that the probability that he will have recovered by the time of the match, it is 1 over 4. That implies when he recovers, he will play the match. Meaning in this case, him recovering, it is 1 out of 4. When he recovers, he will play. Meaning, not recovering shall become 1 minus a quarter, which will become 3 divided by 4. Now from this one, they say find the probability that his team will win. That implies his team can win when he's playing, likewise it can win when he's not playing. Therefore, the probability of his team winning shall give us a quarter times 4 out of 5. Then plus, in this case we have the 3 out of 4 times, this is 2/3. So these would cancel by 2 ones, giving us here 2. Of course, these would go, giving us 1 out of 5 plus 1 out of 2. 2 times 1, it is 2. 5 times 1, it is 5. 5 times 2, that is 10. Giving us here 7 divided by 10. Therefore, the probability that his team wins becomes 7 out of 10. 2011, paper 2, number 15. This one says, box A contains 4 red sweets and 3 green ones. Box B has 5 red sweets and 6 green ones. Then I say box A is twice as, it will be picked as box B. Meaning if I let box B be X, they say box A is twice as B. And in this case, if B is X, A will become twice X. Meaning X plus twice X would give us a 1. They say that box A is twice repeat compared to box B. Meaning if box B is X, A will give us twice X. Meaning X plus twice X equals to 1. This will become 3X is equal to 1. Thus X becomes a third. Therefore, the probability of choosing box B shall give us a third, and the probability of choosing box A shall become 2/3, because box A is twice repeat compared to box A. But in this case, because we have 2 boxes together, what I can do, step number 1, begin by choosing the boxes. The probability of choosing box A, it is 2/3, and the probability of choosing box B shall become 1 out of 3. So I have this, and I have that, and I have this, likewise that one. They say that box A contains 4 red sweets and 3 green ones. I can select R represent red and D represent green sweets. So it implies in this case R is for red and then G is for green. They say box A contains 4 red sweets and likewise 3 green ones. Then likewise box B is comprised of 5 red sweets, 5 red sweets, and box then 6 green ones, and 6 green. Then they say that if a box is chosen at random, I'm done. This part, I'm choosing a box. Choosing box A, it is 2/3. Choosing box B, it's a third. Then they say that, and 2 sweets are removed from it, one after a time without replacement. This simply means from here, I can have red 1, I can have green 1. This becomes 4 divided by 7. This becomes 3 divided by 7. I come into this, and that. This becomes red 2, which becomes, if I pick 1, they will become 3 over 6. This remains constant. This becomes 3 over 6. This becomes green 2. This becomes green 2. If I pick 1, becomes 2 divided by 6. If I pick here, this remains constant. That is 4 over 6. This becomes red 2. Likewise, when I come here, when I choose a red 1, this becomes 5 over 6. This becomes green 1. This is 6 over 11. Sorry, 5 over 11. This is 6 over 11. When I choose here a red 2, this becomes 4 over 10. This remains constant. That is 6 over 10. This is green 2. This one is green 2. This becomes red 2. This one, if I choose from green, it will become 5 divided by 10. This remains constant. That is still 5 over 10. This becomes a tree diagram. But they say that part A, find the probability that the 2 sweets removed are of the same color. Same color meaning red, then likewise green. Probability of getting same color shall give us 1 2/3 times 4 over 7 times 3 over 6 plus same color green. I have a third times 6 over 11 times 5 over 10. So this one, simplifying, of course these would cancel. I would say by 2, by 2 I get a 3. 2 times 2, that is 4 divided by 21 plus by 3 ones, this gives me a 2. By 2 ones, this becomes a 5. This will cancel, giving us 1 over 11. So I'll say from there, for simplifying, I have this times that. 4 times 11 is 44 plus 21 times 1 is 21. Then divide by, this becomes 2, 3, 1. This one adding, I have 60. This becomes 65. Divided by 2, 3, 1. So the probability of having same colored sweets will give us 65 divided by 2, 3, 1. (2017) paper 2 number 5. 2017 paper 2 number 5. It says that a box A contains 1 white ball and 1 blue ball. We have in here, I would say let W represent white, and then likewise B represent blue. Then they say that this box A contains 1 white and then 1 white blue. Then they say box B contains only 2 whites, 2 white balls. Then they say if a ball is picked at random, find the probability that it is part A white. In this case, because we have 2 boxes, box A and box B, that implies boxes A and B have same chances of being picked. Meaning step number 1, first choose a given box. The chance of choosing box A shall become 1 divided by 2. Likewise, the chance of choosing box B still would remain 1 divided by 2. They have equal chances. But they say that box A contains 1 white ball, they have 1 W, Blue meaning white. Likewise, one blue ball. We are having one blue ball. Likewise, box B contains only two white balls. Only two white balls. Meaning this one has only two white ones. It has nothing like blue. Then they say that if a ball is still at random, find the probability that it is white. Meaning in this case, we come here, getting a white one will give us 1 divided by 2. Getting a blue, it is 1 out of 2. Here, getting a white, it is 2 divided by 2. Then here it becomes 0. Then they say find a chance that it's white. The probability of getting a white ball. A white one, it will become this times that. It's a half times a half plus a white one, it is this times that, giving us a half times 2 divided by 2. This will become 1 divided by 4 plus this becomes 2 divided by 4. Giving us LCM is 4, this becomes 3. Answer giving us here 3 divided by 4. However, we have the two parts in this question. They say part B, find the probability that, remember part B, which is part B, that it is from box A, given it is white. Find the probability that it is from box A, given it is white. Find the probability that it is from box A, given it is white. This one becomes probability of A intersection W over probability of W. So in this case, A and white becomes this times that, giving us A and white is a 4 half times a half divided by the P of white, it is 3 divided by 4. We have 3 over 4. This becomes a quarter divided by 3 over 4, which becomes a quarter times 4 over 3. This will cancel, giving us a third. Therefore, the probability of getting a ball from A, given it is white, can become 1 divided by 3. 2007, paper 2, number 15. We have both parts, this part A and part B. So part A part, they say a box contains 7 red balls and 6 blue balls. Meaning step number 1, define the event. I could say let R represent red balls. And likewise, let B represent blue balls. They say this box here is comprised of 7 red balls and likewise 6 blue balls. Meaning, in total, we are having 7 plus 6. This gives us a 13. Then they say 3 balls are picked at random without replacement. Meaning, in this case, our first choosing, we are the red one. This is 7 divided by a 13. Then we are having our red 2. This becomes 6 over 13. Then likewise, when I choose a second one, this becomes red 2. This becomes blue 2. This one, if I pick 1, this will give us 6 divided by 12. This remains constant, giving us 6 over 12. But they say 3 balls are picked at random without replacement. Meaning in this case, I would say when I pick a third one, that is R3, there are 6, pick 1, they will become now 5, but divided by now 11. But these remain constant, which is 6 divided by 11. This becomes blue 3. Likewise, when I come here and I choose now from the blue, this is going to be blue 3. When I choose from now this blue, in this case, choose 1, this will give us now 5 divided by 11. This remains constant. this becomes red 3. This will give us now still 6 over 11. And then when I come on the part of this was blue. Blue one was 6 over 13. Meaning, on second picking, this becomes blue 2. When I choose 1 here, they will become 5 and over 12. These remain constant. This becomes red 2 and 7 divided by 12. When I make a third one, when I choose from the blue, which is blue 3, this one, pick 1, it is 4 divided by 11. These remain constant. That is 7 over 11. This becomes red 3. This becomes red 2. If I pick from red, this will now give us 6 over 11. Then these remain constant. That becomes blue 3. This is red 3. If I pick 1 there, this becomes 5 over 11. And therefore, basing on the question, concerning Roman number 1, we say find the probability that they are the same color. Probability of same color. Same color meaning red, 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 and then blue, blue, blue. So I'll say this one shall yield for us red, 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 which is 7 over 13 times 6 over 12 times 5 over 11 plus this is blue, blue, blue. This becomes 6 over 13 times 5 over 12. Then lastly times 4 over 11. Now this one simplified to give us 0.1923. However, there are two parts. There is Roman number 2, which says find the probability that at most 2 are blue. Probability of at most 2 are blue. This means 2 blue, 2 blue, 1 blue, or no blue at all. At most 2 are blue. It means 2 blue, 1 blue, and then no blue at all. This will give me now no blue at all, which becomes 7 over 13 times 6 over 12 times 5 over 11. Then getting 1 blue. 1 blue can be this, and then that, giving us 7 over 13 times 6 over 12 times 6 over 11. Then likewise getting still 1 blue, it can be this times that. That is 7 over 13 times 6 over 12 and then times 6 over 11. Then still 1 blue, it can be 1 blue, this, and that. That is 6 over 13 times 7 over 12 times 5 over 11 plus, and then at most, lastly, getting 2 blues. We are having this, we are having this, we are having that. 6 over 13 times 5 over 12 times 7 over 11. This, on simplifying, then give us 0.6608 as our final answer.